Mathematical modeling essentially wouldn't be the same if we didn't bring in some of the practical problems associated with measurement, right? So we're going to be looking at area type of problems. Now, if you remember, okay, we've got a description of an area, which is going to be a length times a breadth. So we're going to have two things multiplied by each other. We've also got a perimeter associated with an area because we've got the total distance around the object in question. So if we are looking at a specific shape, we need to know the formulas for area, perimeter, etc. for those shapes, right? What we have to do, what we have to do is we have to, first of all, draw it. Yes, draw it. As usual, that's going to be my mantra. So let's have a look. We're saying area problems, okay? Right. Now, basically, when we draw it, let's say we've got a problem, right? Let's look at an example. And here we go, okay? We have 200 meters of fencing. We have 200 meters of fencing. Right? And we are required to construct a rectangle. And we need to construct a rectangle. Right? Okay. What are the dimensions in order to maximize the area? Right? What are the dimensions to maximize the area? All right. Now, how do we set about this? Well, first of all, they have told us it's a rectangle. So we are going to draw the rectangle, right? And we know that we've got X and we've got Y. So the area is equal to X times Y. Okay? Let's put down what we know. Okay? The next thing we know is they tell us we've got 200 meters of fencing. What does that mean? It means that we've got enough to go around the perimeter. That's it, isn't it? They have told us this 200 meters here, they've told us it's the perimeter. Correct? So if it's the perimeter, we can then work out some functions. We can have a field. Well, excuse the pun. Right. So that's the area. Next we've got perimeter. What is the perimeter? The perimeter of this is going to be, well, it's a rectangle, so that's Y, that's X. So it's going to be 2X plus 2Y. And that must be equal to 200. Therefore, X plus Y must be equal to 200. There we go. 1 and 2 simultaneous linear equations. Not linear this time, but simultaneous equations. How do we do it? We take the simplest one and we rewrite that in terms of just one variable. So therefore, what did I do? I wrote it as X. So I said Y is equal to 200 minus X. Then I substitute, because remember what I said in the section on simultaneous equations, the bulk of these are substitution type problems. So we do a substitution and we say substitute where? Into equation 2. Almost call that equation 1. Right. So what do? We then get area is equal to X times, and Y we can say is 200 minus X. So that is going to be equal to 200X minus X squared. Right. So what have we got? Now we need to maximize that. In other words, what value of X, what shape is that? First of all, let me just tidy it up, because what is it? That is let's rearrange, minus X squared plus 200. It is a parabola, isn't it? So therefore, it's a negative parabola, okay? And Yeah, you can actually draw it. Okay? It's a negative parabola going up this way, isn't it? Okay? Like that. So how do we find the maximum value of a parabola? We look at the turning point. So we say x, okay, for the turning point of the parabola, what do? Well, we say it's equal to minus b over 2a, correct? Minus b over 2a minus b in this case, okay? Let's have a look. X is going to be 0, isn't it? Okay? Minus b, okay, over 2a. All right? Right. Now, therefore, what do we say? We can go ahead and we can say, okay, then let's have a look. Well, let's solve it. Okay? Let's have a look. Where does it cut? It cuts up there at the 200, doesn't it? So let's find what are the values of x. We can find it there. And what is the turning point? Is going to be at 200, isn't it? 200, Kevin, 200 minus x there. So minus b over there. Sorry, my turning point. Hey, Kevin, my bad. Sorry, guys. Let me just redo this. Okay. This is a 200. See, I forgot the x out there. It's 200. So minus b is minus, oops, that's not going to help. 200. It's still a negative parabola, right? Minus 200 over 2a, which is 2 times minus 1, which is minus 200 over minus 2. All right? 100, all right? 200. Oh, my word. Look at my mistakes here. Look at this. See, everybody makes them, guys. Right? What did I not do? I did not divide through, because I'm in a hurry, I didn't divide through by 2. That's a 1. And I've got my notes right in front of me, hey? Can you believe it? But it shows you. That's the kind of mistake we make when we're in a hurry. Okay? So essentially, we've got that. Now, all right, is equal to 100. So I've still got to correct in here, haven't I? Oh, my word. Come on. 100, 100. Okay, everywhere it's going to go. And I'm going to end up with eventually minus x squared plus 100. Okay, because that's 100. Okay, there we go. So we're going to end up with 100, which is going to be 100 over 2, which is going to be 50 meters. So my x is equal to 50. Therefore, 50 times y is going to be equal to, in this case, 50 times y, all right, is going to be equal to the area, isn't it? But we need y equal to area. Therefore, let's have a look. X equals 50. Therefore, we just basically put y is equal to 100 minus x from the top, from up there. Okay, 100 minus x. So that's going to be equal to 50. Okay, so essentially we've got 50 times 50. Okay, so my area is going to be 2,500. 50 times 50. Right? It's in other words given us a square. A similar problem, all right, is where they tell us the maximum available fencing is 100 meters. So it's the same problem, similar. Okay, this time I must make sure I divide through by what I need to. So we've basically got maximum fencing is equal to 100 meters, right? And they say we're going to be doing this. This here, okay, over there is an existing wall, hedge, fence, anything. Could also be at the bottom, right? Same recipe, same things apply. What do? We call the one x and the one y, and we say area is equal to x times y, and they want us to find out the maximum area. What do? We do the same thing. We say area is x times y, perimeter 2x plus 2y is equal to 100. Therefore, x plus y is equal to 50. And did Kevin divide through this time? Sorry. See, it's 2. I'm going too fast, aren't I? It's 2x plus y. 2x plus y is equal to 100. Okay? Sure. These are the easiest, eh? And look, what do we say? Let's just take it. X is there. Oh, my word. X is there and x is there. So what do? We take x, 2x plus y is equal to 100. That's the amount of fencing I've got. What's the next step I do? Next step is I say, therefore, y is equal to 100 minus 2x, and substitute now. Substitute it in. So what do? We say, okay, I've got area is equal to x times y is x times 100 minus 2x is going to be 100x minus 2x squared. This is minus 2x squared plus 100x, okay? And that's going to give me that. Now I say, okay, minus bx for the turning point is minus b over 2 times minus 2, which is minus 100 over minus 4, which is equal to 25 meters. Therefore, if that's 25 meters, let's work out 50. So this y must be equal to, let's have a look. This is 25. Let me just get let's just use a green. So this is going to be 25. This is 25. I've got 100, 25. This is going to be 50 meters, isn't it? I could have worked it out straight from the thingy. Well, let's go. Y is equal to 100 minus 2 times 25, which is 100 minus 50, which is 50 meters. My apologies for the previous one not dividing through by 2. All right. So in all of these cases, they're kind of going to be the same, right? Let's take a slightly different one here. A rectangle has a perimeter of 140 centimeters and a diagonal has a length of 50 centimeters. Calculate the length and width. Okay, so let's have a look at this one. Okay. Example. They've told us that a diagonal across this guy, okay, there has got a length of 50 centimeters. Okay, a rectangle has a perimeter of 140. So we write down perimeter equals 140 centimeters. Diagonal is 50. Calculate the length and the width. So this is L and this is X. Doesn't matter if you call it W and L or whatever, X and Y, all right? Let's just change it to X and Y, all right? Because we're used to that, all right? So therefore, the perimeter is going to be 2x plus 2y must be equal to 140, correct? So x plus y is equal to 70. Kevin, divide through by 2 both sides. Can you see? That's because I didn't do the division properly. I should have done this, right? Okay, just to make sure that we get it. Right, therefore I can say that y is going to be equal to 70 minus x. There she is. Then they want to know, calculate the length and width. Now, hang on, how we do that? Well, we've got another piece of information. The other piece of information is the diagonal. Let's have a look. Can you see that x squared plus y squared is going to be equal to 50 squared? So therefore we say x squared plus y squared is going to be 50 squared is 2,500. All right. Now, what's the next? The next step is to say, all right, let's see. Oh, but hold on. I know y. So I can substitute in here. So I can say x squared plus 70 minus x all squared equals 2500. How do we do that? Basically what we're going to do is we're going to go to the side and we're going to do 70 minus x and 70 minus x, and we're going to take our calculator and work that lot out. All right, 70 times 70, remember, put them in. 70 times 70, 4,900. Yep. Minus 140x. Okay, and then plus x squared. Then let's transfer that back. So that's going to be x squared plus 4900 minus 140x plus x squared is equal to 2500. Can you see the numbers here? They're not straightforward quadratics anymore. They've got slightly more of a real feel to them. All right? They're actual kind of numbers that we're going to be using. Okay? Let's have a look. This comes down to 2x squared minus 140x. All right. Plus 2400 equals 0. Basically, we just bring it all together. And lastly, I can divide through by 2. X squared minus 70x plus 1200 is equal to 0. Factorize, and we get x1 is equal to 40 and x2 equal 30. Can you see here we are getting a positive number, right? And what are we measuring in? It's a distance, isn't it? X is a distance, so it's going to be 40 centimeters and 30 centimeters. Okay, what do we do next? Next we need to find y. Therefore, we're going to substitute in. Where would you go? You'd go into x plus y equals 70. Therefore, 40 plus y equals 70. Y is going to be equal to 30 centimeters. But it's the same. So I'll go x plus y is equal to 70 here. And we'll get 30 plus y equals 70. Therefore, y is going to be equal to 40. Right? So there is an available answer for x2 in this case. Right? So what do? We've got some area problems. This session is a little shorter than most. An area problem. Don't do what Kevin did and forget to divide both sides by 2. Okay? That's just plain silly. Okay? So when you've got an area problem, right, what do? You are going to relate, okay? You are going to relate area. In other words, A of x, maybe y, is going to be x times y or something like that. You are going to then take your perimeter. Okay? Perimeter is equal to something else. Then you are going to equate them because they will tell you the area is this. Work out the perimeter or the breadth or the length, right? Then when you see problems which have the word the maximum, right? Those are generally problems involving a parabola, upside down parabola. Why? Because the maximum value of the function, the f of x, right? I'll leave it at that. The function of x is equal to the y value of the turning point, okay? Or the x value if we're solving for it in the x-axis on the domain, right? So it's essentially the x that gives you the y, okay? Because we've let it equal x, all right? So when we are solving this, the y value is that, and the x value, if we use x unknown, all right? So in all of these area type of problems, x, I want to write that neatly, unknown, okay? It's the x value because x is the one we're plugging in, isn't it? X is the unknown entity in this case, right? So therefore, in all these, that's what you're going to do. There isn't a specific little scenario planner here. All you do is you take, it could be a circle, a triangle, a rectangle, all right? Those are the kinds of shapes. So you need to know your circumference and your area for a circle. Your triangle, half base times height. Remember, it's half base times perpendicular height. Okay, and remember the perpendicular height, just in case there's one coming up in your near future, all right, the perpendicular height of this triangle, okay, is actually there, isn't it? That's h. And this is then the base, because we measure the height from the base. Correct? Okay, so that brings us to the end of that. It is a short one. In the next session, we're going to start looking at number patterns. We're going to go through arithmetic and quadratic, okay? Just going to mention geometric, all right? But we're going to focus on those. Cheers, thanks for watching, and we'll see you in the next one. Bye.